Okay, students. Now, I want to talk to you a little bit about exponents. Because really, what are exponents? Well, exponents are repeating multiplication. So, how do we repeat multiplication? I mean, it's pretty easy. I mean, I take a number like, I don't know, 5. Okay, and I just keep multiplying it over and over and over again. Now, after a while, this kind of begins to be a little bit silly and very long. So, there's an easier way to write this. So, instead of saying just writing 5 times 5 times 5 over and over and over again, why don't you just write it once? Okay? And we'll call that the base. All right, because we're building it off one number that keeps repeating, so they'll make that the base number. Now, how many times am I actually multiplying 5? Well, let's count. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so now this 10 is the exponent, and you know what? It's okay. Since that's the exponent, now I want to get a little bit into what this number actually means. See, it's not a real number, okay? It's not something that I can, really do too much to. I can't multiply these two numbers together. I mean, obviously if I multiply 5 10 times, I'm not going to get 50. So multiplying these two numbers isn't going to work. It's what's called a notation. And what a notation is, it sounds like the word note. If it sounds like the word note, well, I mean, what are notes for? I mean, you get a note. Some of you might get a note on the refrigerator from your mother saying, "Hey, throw out the trash." Okay, it's a reminder. All right. So this little number, this little 10 in the upper right-hand corner, it's a reminder to us. It's a reminder on how many different times I want to multiply the number 5. In this case, I'm going to multiply the number 5 10 different times. That's it. Now, since I'm dealing with multiplication, it gets a little bit different. Let me show you a few things. So what if I had a number like 2 to the third power, okay? Well, what does that mean? Well, I'm multiplying the number 2 3 different times. And if I multiply 2 times 2, that's 4. And I multiply 2 again, that's 8. Well, what if I had 2 to the third power times 2 to the fourth power? Well, okay. Now, see, a lot of you right away would tell me it would be 2 to the 12th power. That's wrong. And here's why it's wrong. Watch. Let me expand both of these for you to understand what we're talking about. See, 2 to the third power, I'm multiplying 2 3 different times, right? Like 2 times 2 times 2. 2 to the fourth power, I'm multiplying 2 4 different times. Now, how many times am I multiplying 2? 1, 2, 3, 4, 5, 6, 7. See, so it's 2 to the 7th power. So what am I doing to my exponents? Well, since 3 plus 4 is 7, then really what I'm doing is I'm adding the exponents together. Because remember, an exponent is a notation. It's a note to yourself. So you're just counting how many times am I multiplying. And as long as you can remember that, how many times am I multiplying, you'll be in good shape. Here's a few examples. So if I had like 2 to the second power, whoops, not add, that's wrong, times 2 to the fifth power, okay? How many times am I multiplying 2? Well, I'm multiplying 2 times here, and I'm multiplying the base 2 5 times here, so I'm multiplying the base 2 7 times total. So you're just counting. So what if I use x instead, like x to the fourth power, and I had x to the seventh power? Well, how many times am I multiplying x? 4 times. And how many times am I multiplying x here? 7 times. So how many times am I multiplying x total? 11 times. Remember, exponents are just counting how many different times I'm multiplying. What if I had like two different bases? What if I had like x to the fourth power? And what if I had y to the fifth power? Can I combine these? No, absolutely not. Because I don't know what's going on with x and I don't know what's going on with y. So I'll tell you what, why don't I just put these two together and really not do too much more. You know, I mean, I know I'm multiplying x 4 times. I know I'm multiplying y 5 times. And I can't do anything more than that, so I'm not going to try. Keep that in mind. When you have different bases, don't mess with it. It's not really a good idea. Ever. Okay, so when you're multiplying, you add the bases together. Well, what if you're dividing? What if I had like x to the 7th power divided by x to the 3rd power? Well, if you're not sure, and here is my recommendation, just expand. Watch. How many times am I multiplying x? 7 times? So let's just write x 7 times. Watch. Now, how many times am I multiplying x to the 3rd power? 3 times. Now, let's just cross out. Now, if x is the same, x divided by x, so that just cancels. Let's just draw a line through it. So let's just draw a line through these x's because they cancel out. Now, how many times am I multiplying x? 1, 2, 3, 4. So I have x to the 4th power here, and I have 1 here, which is the same as x to the 4th power. So what happened? Well, it looks like I subtracted my exponents because 7 minus 3 is 4. So I was multiplying 7 x's, and through division, I canceled 3 of them. How many x's am I multiplying still? 4. So, you know, a lot of you are kind of like, well, wait a minute, you know, shouldn't I be multiplying? Shouldn't I? No, no, no. You can't multiply because we're just counting how many times we're multiplying. It's a little bit of a new idea for some of you. Would there be a case? Now, some of you might ask, like, well, is there a case where I ever multiply the exponents together? And yeah, actually there is. It's when you have parentheses. Let me show you what I'm talking about. See, because the parentheses is a group, right? So let me expand. When in doubt, always expand your group. So I have like 3 x's here, right? See that? X to the 3rd power. How many times am I multiplying x? 3 times. Now, how many times would this group repeat itself? 4 times. So let's write that group 4 times. Whoa, that's kind of weird looking. And there's your 4th group. Okay, so how many x's am I multiplying total? So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So how many times did I multiply x? 12 times. And so what did I wind up doing to these exponents? Well, 3 times 4 is 12. So when you have parentheses and you have an exponent inside the parentheses and an exponent outside the parentheses, then you can multiply those together. One last one that I can think of off the top of my head, and this one's a nice one too. What if your exponent is negative? Now, you remember, negatives are opposites. See, like, if I had, before I had, 4 plus 3. Well, what if it was 4 minus 3? Oh, all of a sudden, instead of, like, counting, I'm canceling. I'm doing the opposite. And what if I had, a negative to anything is an opposite. So what's the opposite of multiplication? Because since an exponent is multiplication, what if I put a negative next to the exponent? So let's kind of look at it from the standpoint of an exponent, okay? I know that x to the 3rd power, I'm multiplying 3 different times. Well, if I took the same idea, but I made it negative, what's the opposite of multiplying? Dividing. And here's what division will look like when you have a negative exponent. Because see, remember, everything's a fraction. Okay? Every single thing here is a fraction, okay? Because we just don't write it as fractions because it's kind of pointless. But, if I've got a whole number, it's always a number divided by 1. Always. Because we're always counting it just once. Well, if it's... So, what would it look like here? I'll tell you what it would look like. It would still be a fraction, but instead of x being in the numerator, now x is in the denominator. Because it's dividing, right? And anything in a fraction in the denominator is for dividing. Anything in the numerator in a fraction is for multiplying. Keep that in mind. Anything in the numerator is for multiplying. Anything in the denominator is for dividing. So if that's the case, then if I see a negative next to an exponent, that's division. And there's a few different ways I can write division. The first thing I can do is I can have a negative exponent. The second thing I can do is I can write that exponent and it'd be positive. Notice that this exponent here is positive, and I can write that in the denominator. Either way, it means the same thing. Another way I can write it would be I write one big fraction, and then I just write my x's in the denominator. All three mean the same thing. They're all division. A negative exponent, anything in the denominator, same idea. So do keep that in mind, because those are some things that will come up when you take tests from time to time. So one other thing, just before this video ends, what if I had a negative exponent in the denominator? Well, it would just switch positions. I mean, this is division, right? Because it's in the denominator. But wait a minute, I see a negative. So it can't be division because it's the opposite of division. What's the opposite of division? Multiplication. So notice what I did, it was pretty simple, is that I pretty much just moved the expression from one position of the fraction to the other. So if you ever see a negative and it's in the denominator, just move it to the numerator, make it positive. If you ever see a negative exponent and it's in the numerator in the fraction, move it to the denominator. And that's pretty much all you have to do. That's all you have to really remember, and you'll be okay. I hope this helps.